Hey guys, I just wanted to put together a quick video just to remind you kind of what we're working on and just give you some information that will help you on your homework that you have this weekend. I will be taking that up after the weekend. But today we worked on composition of functions. And I did give a numerical example like you see here, a table, and I did not make copies for you guys, so feel free to pause this at any time and just write some things down. But I'm going to just show you a few examples, and then we're going to move on to some graphical examples because I did not get to those today. So they're not hard, but I did want to just show it to you because I felt like I owed that to you. So here we go. So if you look right here, and these are some pretty cool problems that we put together here. So this is -3 h of 0 times g of -3. So let's say use the table to come up with that solution there. So the first thing I'm going to do is multiply the -3, and then I'm going to find h of 0. So 0 is my input, so here's my input up here, and then my output for the three functions is going to be these three rows. Okay, so 0 is my input, so h of 0, go all the way down to the bottom to the h function, so h of 0 is 2. So I'm just going to replace that with a 2, times g of -3, so -3 is my input, plug that in the g function, and I get -2. And then work that out, we get a -6 times a -2, and we get a +12. Okay, just using a table to get this information. Here I have 2 times g of -1. So 2 times, plug in a -1 into the g function, and I get 7. Over f of -2, so plug in a -2 to the f function, and I get 3. And we simplify that, and we get 14/3. Okay, easy stuff. Let's move down here. Here's one we haven't seen yet. So, you can have as many functions as you want, when dealing with composition. So here's one with 3 different functions. So, we're going to work inside out here. We'll plug the -1 in, then we'll plug that into h, then we'll plug that into g. Okay, so f of -1. If you go back to the top of the table, let's see if I can zoom out a little bit. Let's see if I can get it all in there for you. It'll be closed, so I'll just be sliding the paper back and forth. So f of -1 is 2. So now we're looking at g of h of 2. Now let's find h of 2. So going back to the table up there, h of 2 is 0. So I'm going to replace h of 2 with 0. And then now I'm going to find g of 0. So g of 0 is -2. And there you go. So again, I just took the -1, plugged it into the f function, took that output, made it the input for h, and then took that output and made it the input for g, and then I got a final answer of -2. And then I thought this was a good problem, and this will help you for your homework. So let's look at this guy right here. What is this? Letter N. It says if p of x equals the absolute value of 2x minus 3, then for what values of x is p of x equal to f of g of negative 2? So I'm going to go back to the table and figure out what f of g of negative 2 is. So let's find g of negative 2 first. G of negative 2 is the second function there. G of negative 2 is 1. So now let's find f of 1. So we know p of x equals f of 1. And then now I'm going to go back to the top and find f of 1, and you'll just have to trust me. F of 1 is 4. So now let's take that p of x and we'll say absolute value of 2x minus 3, there's your p of x, equals 4. Now some of you saw this when finding intercepts earlier in the week, working with the absolute value. If I'm going to drop those absolute value bars, then what I want to do is take that 2x minus 3, set that equal to 4, and then do it again and set it equal to negative 4. That's what absolute value tells us. We can get a 4 in here. We can also get a negative 4 in here. And either one of those will be a true statement. So set it equal to 4. Also set it equal to negative 4. And then we solve. There's 1. Add the 3. And then divide the 2. Let me raise that up a little bit. There you go. Okay, let's look at some other examples. There's just one on this page that I wanted to go over. Thought this was a good problem. See if I can zoom in a little bit. There we go. So here f of x is equal to 2x squared. Let me slide this over so you can see the functions. You may want to write these down. F of x equals 2x squared minus x plus 3. And g of x is equal to 5 minus 2 times x minus 3. Okay, we need those two functions. So what we're going to do is we're going to find f of x minus 2, and then we're going to subtract g of 2x. So let's do it. Let's find f of x minus 2 first. So looking up here at the f function, we'll say 2. Then I'm just going to plug in x minus 2. Minus, and then I'm going to plug in x minus 2 again. And then I'm going to add 3. So there's my 2x squared minus x plus 3, my f function. So let's simplify this. We get 2, let's see, x squared minus 4x plus 4 minus x plus 2 plus 3. Let's keep going. 2, let's say 2x squared minus 8x plus 8 minus x plus, we'll say 5. And then there's some more like terms. Let's see if I can take it over this way a little bit. And I'll get 2x squared minus 9x plus 13. Okay. And then I'm going to find g of 2x. So let's do that real quick. Let's see, I can use a different color here. So g of 2x so 5 minus 2x minus 3. I just plugged 2x in for x right there. Simplify that, and we get 5 minus 4x plus 6. Combine like terms, and we end up with a negative 4x plus 11. Now go back to the original problem. So we know what f of x minus 2 is, 2x squared minus 9x plus 13. And we know what g of 2x is, negative 4x plus 11. So now let's just find the difference of those two functions. Okay, so we'll say that f of x minus 2 minus g of 2x equals 2x squared minus 9x plus 13. There's f of x minus 2. And we're going to subtract negative 4x plus 11. So we get 2x squared minus 9x plus 13 plus 4x minus 11. And then combine like terms. You're almost there. 2x squared negative 9x plus 4x, 13 minus 11. And there you go. That's a good problem. I wanted to show you that one. Now, the very last thing that I want to get into is just some graphical representations. And I mean, we don't have to do all of these, but if you want more practice on this, I can get it for you, or I can show you everything on this video, and so you can work through any of this. But let's do a couple of these where you have negative 3 times f of 2 plus g of negative 3. So let's start there. So we have negative 3. Now how do we find f of 2? So up here you have the f function, you also have the g function. So if I plug a 2 into the f function, looking for f of 2, if I plug a 2 in, I get 2, because there's that point. That point is 2, 2. So if 2 is my input, then 2 is my output. 2 is my x, 2 is my y. So f of 2 equals 2. Now go find g of negative 3. So when I plug a negative 3 in, I get negative 2. Now I can work it out. Negative 6 minus 2 equals a negative 8. So it's basically the same thing you do with a table. You're just pulling these values from a graph. Okay, let's find g of 3. So g of 3 equals 1, because this point is 3, 1. So g of 3 equals 1. F of negative 1 equals negative 3. And you get 4. Okay. Let's just do one more. Right here, let's run it through the full composition there. So let's find g of 0 first. So we're finding f of g of 0. So find g of 0. So go to the g graph. G of 0 equals 2. There's that point, 0, 2. So now I'm going to find f of 2. So go to the f function. F of 2 is 2. There you go. So I'm going to zoom out so you can see more of this paper, and feel free to practice with any of those. I can show you a key later on. In fact, I'll just go ahead and put the key on there now. No, I don't have the full key. I lied. I apologize. Okay. But hopefully this will help you out with homework 5A, and I will see you guys on Tuesday. Have a great day. Great weekend. Bye-bye.